Hey, what's up, Logic fans? It's Ash again. We're coming at you with section 4.4 today, our fourth section on quantificational symbolization. And today we're going to build on our work in 4.3 where we introduced the mechanics of the universal quantifier. And with that under your belt, what we're going to do is talk about the meaning of the universal quantifier today. So these two sections together should give you a more complete picture of what the universal quantifier is and what it's all about. Let's rock. Alright everyone, so the meaning of the universal quantifier is best explained via the notion of a domain of discourse, or at least by introducing the notion of a domain of discourse. We tend to symbolize a domain of discourse with just the capital D. What is a domain of discourse? Intuitively, a domain of discourse is the range of objects under discussion, alright? I'll give you plenty of examples in a second. Formally, all right, rather than intuitively understood, a domain of discourse is let's call it a set of objects, okay? And I'm going to have to specify a few things. So any set of objects. So the set of students in our logic class, that it could be a domain of discourse, okay? The set of Harry Potter characters could be a domain of discourse. The set of all colors, red, yellow, blue, green, that could be a domain of discourse. The positive integers, 1, 2, 3, 4, okay? All of those things can be domains of discourse. There's only two main points I want to make about them, all right? A domain of discourse has to be well-defined. Well-defined meaning for any given object, it has to be unambiguously clear whether it's a member of that domain of discourse or not. So if our domain of discourse is the positive integers, 1, 2, 3, 4, all of them, all right, then it's unambiguously clear that, the pen you're holding in your hand right now, that pen, that is not a member of that domain of discourse. So it's well defined in the sense that for any given object, it's absolutely clear and wholly determined whether it's in that domain or whether it's not in that domain. So they've got to be well defined, and also a domain of discourse, as I've noted already, is possibly infinite. Doesn't have to be infinite. Could be finite. Could be the first 5 positive integers. 1, 2, 3, 4, and 5. That's it. That's my domain of discourse. But it could be any set of objects that's well defined and possibly infinite. Okay. It can't include contradictions, as we'll talk about. You might wonder how that is. It'll have to do with a certain way of presenting a domain of discourse later. But yeah, any sort of logically consistent, well-defined, possibly infinite set of objects. Okay, so no object can be both in there and not in there. Okay, that would create a contradiction, for example. These are all possible domains of discourse. All right, let's look at how domains of discourse help shed meaning on the universal quantifier and some actual concrete examples. So my first question for you, let's build up nice and easy, all right? Simple case. So here's a sentence. You learned that this was a sentence and how to prove that it is a sentence in 4.3. It's got the universal quantifier on it, okay? And here's what this means, all right? This is what the property constant, what property it is standing for, okay? What does this sentence mean in ordinary English if you had to take a guess at it? Okay, what this means in ordinary English is everything is red. For all x, x is red, okay? Now, what we're going to do is we're going to introduce the notion of a domain of discourse. So the idea is that when you have a universal quantifier, there's always some domain of discourse that everything ranges over. Okay? So the universal quantifier ranges over some particular domain of discourse. So, for example, let's get a couple of different domains on the board so you can see this. So we're going to start really simple here, okay? And our first domain of discourse, D sub 1, okay, is going to consist of 2 red balls and nothing else. So in the whole wide world, nothing else exists except 2 red balls, okay? And that's domain of discourse 1. Domain of discourse 2, it has a red ball, a green ball, and nothing else. So there's 2 balls, one's red and one's green, right? On domain of discourse 3, there are 2 green balls and nothing else. And this says everything is red. Now, is the statement everything is red true or false on D1? Is it true or false on D2? And is it true or false on D3? Okay, pause now and see if you can answer that question or those questions. Okay, so the idea here, what you're supposed to be doing is you're supposed to be thinking about this sentence, everything is red, and you're wondering whether it's true or false on a domain of discourse where there are two red balls and nothing else. And the answer there is that yes, the sentence is absolutely true there, okay? But this same sentence, is it true if we're thinking about domain of discourse too? So if what exists is a red ball and a green ball and nothing else, is it true that everything is red? The answer there is no, that is not true, that is false, okay? So what about this third case where we've got two green balls and nothing else? Is it true that everything is red? Absolutely not, right? That's going to be false as well. So the idea is that we can translate a sentence like for all x fx as meaning something like on domain of discourse D, everything is red, right? So the idea is that everything, that means something like everything in our domain. Maybe we could translate it that way. Everything in our domain, D, satisfies this description. So this is the way I put it, that sometimes satisfies this description. It is red. Everything in the domain satisfies this description. It is red. Everything in our domain is red. Okay, that's what this sentence means. So the idea is that universal quantifiers are always to be understood as having implied in some way some domain of discourse. Some domain of discourse is in play, and it's up to the context or the reader or your logic book to tell you which domain of discourse is in play. All right, so that's the basic idea. Right? We can understand the meaning of a universally quantified sentence by saying, okay, we've got some collection of objects that we're talking about. And then someone says everything with respect to that collection of objects is a certain way. And then we can assess whether that statement is true or false depending on what collection of objects is in play, what the domain of discourse is, and what exactly was asserted. Let's try a few more examples. For instance, check out this sentence, all right? This sentence, is that true or false on domain 1? Is it true or false on domain 2? And is it true or false on domain 3? Pause now. Okay, so hope you've had a chance to work this through, but first thing you have to ask yourself is, what does this sentence say? And it says, everything in the domain is such that, or satisfies this description. It is not red, right? Everything in there, all right? Every single thing in the domain is such that it satisfies this description, right? This description right here. It's not the case that it's red. It's not red. So one thing I like to do with students is I like to ask them to sort of think about it this way. All right, think of it this way, all right? And sometimes I talk about this as like Santa's bag. So this green thing here is like a bucket, or it's like Santa's bag. And you don't necessarily really know what's in it, but there's a bunch of stuff in it, let's say, okay? And you don't really know what those things are. So you've got like a blue thing here, a purple thing here, an orange thing here, a red thing there, and a yellow thing there, okay? Now the idea is not knowing what's in there, all right? You reach in there and you're picking something out at random. Right? And if you're making a universally quantified sentence, right? So this whole thing, this represents like our domain of discourse, right? Santa's bag with all the goodies inside is our domain of discourse, and we don't really know what's in there. But if we say for all x fx, everything in there is red, the idea is when you reach in there and pick something out, no matter what you pick out, it's going to satisfy the following description. It's red. Right? So obviously in the case of this domain of discourse, right, that's not true, because what if you picked out this thing? If you picked out that thing, you would have picked out a purple thing, right? So it's not true that everything in there is red. But the idea is a universally quantified sense is saying everything in the domain of discourse satisfies a certain description. In this example, it's red. Okay, is the description being satisfied? So I hope you find it useful to think of it that way, and I rely on that kind of heuristic from time to time as well. It just helps me get a concrete idea of what's being stated. So back to the problem at hand, right? You know, we're imagining that we're reaching into Santa's bag, and it's saying no matter what you pick out of there, everything in there, no matter what you pick out, satisfies the following description. It's not red, right? It lacks the property of being red. So you reach in there, you pick something out, you pull it out, you look at it. If this statement is true, that thing you pulled out, no matter what you picked, it better be not red. You put that aside, you pull out the next thing, it better be not red. You pull out the next thing, it better be not red, right? No matter what you picked out, it better satisfy this description, not being red, okay? So that's what the sentence means, and I hope that helps. Now, knowing what it means and understanding a little bit better, if this is Santa's bag, right? Is the sentence true on this domain? Is it true or false on this domain? Is it true or false on this domain? Pause now. Okay, hopefully you've had a chance to work it through, but this says everything in there, no matter what you picked out, is such that it's not red. Okay, so obviously, you know, on domain D1, that's false, right? This statement is false on domain D1, right? Because the statement says everything lacks redness. Everything is such that it's not red, and this has everything actually being red, okay? What about on D2, right? On D2, is this same sentence, is it true or false? Well, it's also false there. It says everything is such that it's not red. It's true that it's got this thing in there that's not red, right? But it says every single thing in there is such that it's not red. So on D2, this sentence is also false. So D1 false, D2 false. What about on D3? Well, on D3, this particular sentence turns out to be true, right? It's true because it says everything is not red, and look, everything in there is such that it's not red. So everything in there satisfies this description, okay? And so that's the way to understand this, and I hope that you're starting to see now how much a domain of discourse helps understand what the universal quantifier means, because we're interpreting the universal quantifier saying something about a specified domain. Okay, when we get to cases where you don't know what domain is in play, that's a totally different thing. But for right now, some specified domain of discourse is in play, and the question is whether or not the sentence is true of that specified domain of discourse. Okay, so here's the two sentences we've looked at so far. We looked at this sentence, right? And we noted that this sentence was true on D1 and false on the other two. We noted that this sentence was false on D1 and D2, but true on D3. Let's try one more sentence. Let's try, let's try this one as an example. Try it by yourself. I'm going to give you a hint in a second. The first thing you have to ask yourself is what you think this sentence actually means. And then you have to decide whether it's true or false on these domains. I'll give you a hint in a second. Pause now. Okay, my hint for you is as follows. This sentence and this sentence contradict one another, meaning this sentence here is the negation of this sentence. Think of this sentence as P and this sentence as not P, right? So if you were to build this sentence from scratch, going back to what we just did in 4.3, you could build it up and it wouldn't be a problem. So you'd start off with FA, then you'd get for all x, fx. In this case, you would build it from scratch by first building this sentence and then negating it, right? So this sentence here is the negation of this sentence. So wherever this sentence is true, this sentence is going to be false. And wherever this sentence is false, this sentence is going to be true, right? Because it's the negation of it, right? And that's how negations operate. So pause now and see if you can finish it from there. Okay, hopefully you had a chance to do it, but this says, well, let's just do it this way. Since this sentence is true on D1 and false otherwise, this sentence is going to be false on D1 and true otherwise. And I'm going to pick up the conversation of this particular sentence more on the next video. So look for video 4.4b.